All right, we're asked to solve this quadratic equation, 12z plus 5z minus 2 equals 0. We're going to solve this by factoring. The first thing that we need to focus on is getting one side of this equation equal to 0 so we can use the zero factor property. The good news here is the problem that they've given us is already set equal to 0. So the next thing we need to do is to factor this 12z squared plus 5z minus 2. I'm going to do this using the AC method, just so I can describe this. You also can use guess and check. The first thing I do is I multiply my A and C coefficients. In this case, that's negative 2 times 12 to get negative 24. Then what I need to do is I need to find factors of negative 24, or two numbers that multiply to be negative 24 that also add to be the 5, or the linear coefficient here. Just real quick, I'm going to make a factor tree for 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's the entire list of numbers that multiply to be 24. The only key here is I need it to be a negative 24, so I got to give a negative to one of the numbers in each of these pairs. I'm going to give it to the smaller number in each of these cases because I want the addition of these two numbers to be positive. And in that case, I'd always give the negative to the smaller of the numbers. I know all these numbers now multiply to be negative 24. The question is which pairing adds to be 5, and that's this pair right here, and negative 3 and 8. All right, so what I'm going to do with that is I'm going to split up that middle term, that 5z. So I got negative 12z squared. And I write that that positive 5z as negative 3z plus 8z, and then minus 2. And so then I will factor this by grouping. I'm going to pull out a 3z out of this first group here to get a 4z in this first term minus 1. Then I'm going to pull out or factor out a 2 out of the second group, and I'll get a 4z minus 1 also. And as we know, in factor by grouping, it's a key that we get the same binomial factor here in these two terms. I'm going to factor out the 4z minus 1 now to get my final factored form, which is 4z minus 1 times 3z plus 2. All right, so let's go back then to our original problem. Here, I'm going to rewrite this 12z squared plus 5z minus 2 as its factored form, which is 4z minus 1 times 3z plus 2, equaling that 0, and again that 0 being a key component of this. Now what I'm going to do is set each of these factors equal to 0. So 4z minus 1 equals 0, and 3z plus 2 equals 0, and solve each of these. And there are my two solutions. So the solutions to this equation are either negative 2/3 or 1/4 for the value of z. That will make the equation true.